Hello friends, welcome to my channel. Today's session is about the integration by trigonometric substitution. So there are several methods in the class 12th. We are solving one of the method. So we are in the today's session we are solving two problems based on the trigonometric formulas. I think these two formulas I have studied in the class 10th. So you can see the first formula. First formula is 1 plus tan square theta equal to secant square theta, and second formula is sin square theta plus cos square theta equal to 1. So these two formula we are using to solve two problems. First problem is solved by first formula, second problem is solved by second formula. So how to use these formulas, how to substitute? So for that you have to remember these two substitution. If the question given like a square plus x square in the numerator or the denominator, how to solve this kind of questions? So as I named, today's session is about the trigonometric substitution. We have to do trigonometric substitution, all the integration easily. So if in the numerator you can solve directly. If it is a square plus x square, you can take integration. This will be a square x, and that will you will get same answer. If you take the trigonometric substitution also, you will get the same answer. So it is tough if it is given in the denominator. So we will do this kind of substitution. So if the question given like a square plus x square, so what is the substitution for x is a tan theta. So this is for the first problem. For second problem we are using this substitution. If the question is given like this, if the question is a square minus x square in the numerator or the denominator, we will use this substitution to solve the questions. Let us move on to the problems now. So first problem is given in the question, you can see here. So if it is a question integration of 1 by a square plus x square, we have studied this, how to substitute the equations. Answer is substituting the present equation. So substitution is x equal to a tan theta. So if you substituted this in place of x, and we want d theta, because we are substituted in the form of theta, we have to replace dx by d theta. So you want the dx in the form of d theta. So what you have to do, you have to differentiate that substitution with respect to d theta or d theta. So we will get dx by d theta equal to a secant square theta. We want the equation for the dx, so we will take this d theta right side. So we will get dx equal to 8 secant square theta d theta. By resubstituting these two equations, which I marked in the mark, yellow marker, you have to substitute in the equation. You will get this equation. So it will be like, in the place of dx, a secant square theta d theta, and in the place of x, a square tan square theta. You can see a square in common in both in the denominator, and a is a common in numerator. So we can take outside, in the denominator we can take a square outside, in the numerator we can take a outside. So it will reduce to, we will get the answer as a in the numerator, a square in the denominator, as it is secant square theta d theta. And if you take a square outside, the remaining is 1 plus tan square theta. So I think this formula we have studied in the SLC, I have given here, just note it. So 1 plus tan square theta is equal to secant square theta. These are basic trigonometric formulas, right? We will call it as identity formulas. So if you substitute secant square theta in the place of 1 plus tan square theta, you will get it as 1 by a. You can see here a cancel with the square term of the denominator. So only remaining is 1 by a. We will take it as outside because it is a constant. secant square theta d theta divided by secant square theta. So you can cancel that. You can cancel these two. So what is the remaining? 1 by a integration of d theta. We know that integration of dx is always x. We have to do add the c because it can be the function of another variable. So we have to write the c in these kind of integrals. If the limit is given, there is no need of writing c. 1 by a integration of d theta equal to 1 by a theta. Same 1 by a dx if it is given, so it will be x plus c. In the same form, we will get it as theta plus c. We know that the answer should be in the form of x. So, but the answer we are getting is in the form of theta. So, we have to resubstitute the equation. In the first, we have taken as x equal to a tan theta. So, take a that side, it will be x by a tan theta. X by a equal to tan theta. On taking tan inverse both sides, you will get tan inverse of x by a. Tan inverse of tan theta is always theta. We know this equation by the inverse trigonometric method. So if you substitute the value of theta, in the place of this, you will get it as 1 by a tan inverse of x by a plus c, constant of integral. So you can take the screenshot if you want. So I will move on to second problem. So I am moving to second problem. The integration of 1 by a square minus x square is given. How to solve these questions? We have studied the substitution for this kind of questions. If it is a question given like a square minus x square, substitution will be x equal to a sin theta. So you can see here I have substituted x equal to a sin theta. If we differentiate with respect to theta, dx by d theta equal to a cos theta. So if you want the answer in the theta form, so you have to replace dx by d theta. So dx equal to a cos theta d theta. If you replace these substitution, these two substitution in this first equation, you will get it this equation as integration of a cos theta d theta root of a square as it is. In the place of x square, a square sin square theta. We have substituted x as a sin theta, a square term is there, we will write the square term. So if you see the denominator, a square is common between them. So you can take common in the denominator. It will be a cos theta d theta divided by root of a square in the bracket, inside the bracket 1 minus sin square theta. This formula I think you have studied in the SLC. 1 minus sin square theta equal to cos square theta. So you can replace that 1 minus sin square theta by cos square theta, a square as it is. So cos square theta, a square theta in the denominator. So integration of a cos theta d theta divided by root of a square cos square theta. So square term is cancelled with the square root. You will get it as in the denominator as a cos theta only. So a get cancelled and cos theta get cancelled. Here square term of a square is cancelled with the square root of this, and cos square is square term is cancelled with the square root. So you can cancel this. You will get it answer as integration of d theta. We know integration of dx is x plus c. So in the same form, we will get it as theta plus c. So we want the answer in terms of x as the question is given. So you can replace this theta by this substitution. So this substitution will be like this, and x is equal to a sin theta, x by a. You can take a this side, it will be x by a equal to sin theta. If you take sin inverse on both sides, sin inverse of x by a in the LHS, in the RHS you will get it as sin inverse of sin theta is always equal to theta. So we can replace theta by sin inverse of x by a. So sin inverse of x by a plus c, where a is any number, it can be integer, so it should be a real number in the set of real number only. So if you want, you can take the screenshot here.
Okay, so these are the two problems we have studied for the today's session. You can take the screenshot of both. Thank you for watching our channel. Keep sharing this video. Thank you. If you have any doubt, please comment on the comment section. Thank you. Ram Ram.